Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to use Autodistill for automating labeling process for Raspberry Pi 4 latest OS Raspberry Pi Bookworm 64-bit version. Also we are going to use here Google Coral USB for faster object detection. So I have already created the video how to configure Google Coral USB for Raspberry Pi 4 latest OS Raspberry Pi Bookworm 64-bit version. I also create a playlist, so just watch the playlist and then you will get the idea how to configure Google Coral USB for latest Raspberry Pi OS Bookworm 64-bit version. So as I mentioned, today we are going to use Autodistill and we are going to automate the labeling process, and we are going to detect custom object on latest Raspberry Pi 4 Raspberry Pi Bookworm 64-bit version. So before we move to our practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, for that simply open programming Tony Python ID and we are going to just install our packages. But first, as I mentioned, because we are going to use here Google Coral USB, so if you watch my configuration video, then you definitely know we want here a virtual environment. So I have already done with virtual environment for Google Coral USB. So I need to simply go here, run, then config interpreter, then I will choose a particular virtual environment. As you can see, home Pi Freedom Tech Python 3.9, which is basically we are going to use for Google Coral USB Accelerator. So Python 3.9 is basically compatible with Google Coral USB. So I will select my virtual environment. As I mentioned before this video, you need to watch my old video where I have explained how to configure Google Coral USB. So as you can see, we select Python 3.9.12. That's it. So we successfully change our version and we successfully select our virtual environment. Now we are going to download our repository. So I will mention the link. You need to simply copy paste the link inside the web browser. Then go to the code and just go to the code and click on download zip, and it will download our zip format repository. Done. So let's just minimize all these things, open file manager, go to the downloads, and this is what our repository. As you can see, right click and just click on extract here. It will extract our folder. So right click to the folder, cut, and just move the folder inside our home repository, or not repository, basically home directory. So this is what our repository, or we can say this is what our folder. So inside that, of course, we need Google Colab file, then we need video file, then this is what our main code which we are going to use for detecting object with the help of YOLOv8, and this is what img.py with the help of our video file we are going to capture images for data purpose. Done. So first we are going to simply download our video file. So vid.txt, open with text editor. This is the link, mega cloud link, copy it, copy the link, open web browser, new tab, and just Ctrl+V, paste it and hit enter. And then just click on download and it will download our video file. So friends, as you can see, we successfully download our video file. So because I have already video file inside my download folder, that's why the name is basically for clip 1.mp4. So because here it is, as you can see, I have one already inside same video file, so that's why the name is changed. So I will move this one inside the repository. You need to do same thing, you need to move your video file inside our folder, or we can say repository. So just right click and then click on cut, go to the home and then our repository, or we can say our folder, and just paste our video file. So let's just first watch our video file and then we will get the idea what we are going to detect. So here it is, as you can see friends, we have here forklift and the person. This is basically a warehouse. So here we want to detect a forklift. This is what our custom object, and we are going to detect a person. Simple. So this is what our video file, as you can see. So let's get started. First, as I mentioned, we need our images. So inside same repository, we are going to create images folder. So right click, new folder, and mention the name images. And then we are going to open img.py. So open Thony Python ID, where we select our virtual environment with the Python 3.9.12. Go to the file, click on open. Then go to the home, our repository, then select img.py, and here we want to mention our new folder path, images. So right click to the images folder, copy the path and mention here. From images, just remove all the things, remove it, and then just press Ctrl+V. It will paste our new folder path along with the folder which we just created, images. So we have our images folder inside our repository, this one, and then we are going to assign the name for images is basically img. This is the name, and we are going to capture here 400 images. Let's just say 400 images. Done. So here we want to mention our video file name, which is forklift.mp4, forklift just a minute, forklift.mp4. Just save the code and run the code. And as you can see, it started our video file, and it will capture 400 images from the video file, and it will save all those images inside our folder which we create inside our repository, the images folder. So friends, done. We capture all the images. So if you go inside our folder images, and here it is what our images. We have all our images inside images folder. Now simply we are ready, and as I mentioned, now there is no need to open label img software and draw a rectangle, all these things, because we are going to use here Autodistill for automating label img process. So just open Google Colab. So let me open my Google Colab. So friends, as you can see, I have opened my Google Colab. You need to simply open your Google Colab. Then go to the upload, click on browse, and then just go to the repository. This is what our repository, and select the Colab file. Just select it, and now it will upload our Colab file on Google Colab. So friends, as you can see, we successfully upload our Colab file. Now just go to the runtime, change runtime type, and then select T4 GPU, click on save, and then just click on connect. So friends, as you can see, we successfully connect with GPU. Now we are going to run our cell one by one. So let's just run our first cell, import OS. This is what our home directory. Then we are going to create two new folder, images, inside where we are going to save our all the images, and then we are going to create dataset folder. So run the next cell. Then we are going to run our next cell where we are going to install all the packages. So just run the next cell, and now we are going to upload our all the images on our images folder. So here just click on images folder, then this one images folder, as you can see, click on these three dots, click on upload, and then go to the home, our repository, then images folder, and this is what our all the images. Press Ctrl+A, it will select all the images, then click on open. Then you will see this kind of warning message. Simply click on OK, and now it's uploading our all images on our Google Colab machine. Also same time, as you can see, we are installing our packages, so it will take some time. Meanwhile, I will pause video. So friends, as you can see, we successfully install our packages. Also we upload all our 400 images. If I just click here inside images folder, we will see all our images. As you can see, this is what our all images. Simple. So we have done with package installation also we have done with uploading all our images on our Colab machine. Then just scroll down for next cell, scroll down, and then here we are going to mention our dir path and dataset dir path, images dir path and dataset dir path. So click on next cell, then just click on next cell. It will count all the images. We have 400 images. Then for next cell, just click on it, the next cell, it will show all the images. Here it is, as you can see, this is what our data set. Simple. Now let's just scroll down, and this is what our main code, where we are going to detect our object. So here I have mentioned what we are going to detect. As I mentioned, we are going to detect a person. Also we are going to detect here a forklift. So here I need to mention the person is there already, I have mentioned, and instead of excavator I need to mention over here forklift, and here also forklift. Simple. Person, forklift and forklift. That's it. So this is how we need to mention the object which we want to detect. The person is basically prompt, and this is the class, and the forklift, this one is basically prompt, and this is what our class name. Same. Simple. Now let's just run our code. So friends, as you can see, process is started. So it will take some time. Meanwhile, I will pause video. So friends, we have done with auto labeling process. As you can see, the process is completed, and then we are going to simply run our next cell. So just click on the next cell. Here we are going to mention all the dataset path, annotations directory path, images directory path, data.yml file path. That's it. And then length of dataset is 400. And now here we will get the idea what basically auto label detect. Simple. So for that, this is the next cell, and then we have labeling on our objects. As you can see, the green color rectangle for forklift and the red color rectangle for person. So we have successfully auto label our objects. We have forklift and we have person. Now we are ready, and we are going to simply install Ultralytics. Then we are going to install TensorFlow for converting our YOLOv8n. Means we are going to use here YOLOv8n.pt, and we are going to create our own custom model, and then we are going to convert the model for Google Coral USB Accelerator. Simple. So first we need to create a basic model. For that we are going to use a YOLOv8n, the nano model, and then we are going to create a basic object detection model for Raspberry Pi 4. Simple. So for that, here I have mentioned YOLOv8n.pt, then data.yml our file, and then image size. Of course we are working on Raspberry Pi 4, so we need image size 240. Simple. So let's just run the code, run the cell, and it will create. So here I forget to mention, first we need to again restart our Colab machine. So just go to the runtime and then just click on restart session. Just click on restart session, click on yes. It will restart our session. As you can see, Done, connect, and then we are going to install our packages. pip install ultralytics and pip install tensorflow 2.15.1 version. So as you can see, it's installing all our packages. So friends, we successfully install our packages. Now we are ready, and as I mentioned, we are going to create our first basic model. Then we are going to convert the basic model into HTPU format. So let's just run our code. The next cell here I have mentioned epochs 100, and of course as I mentioned the image size 240. So now it will create our basic model using YOLOv8 n.pt, a nano model. So friends, as you can see, process is started 1 out of 100, so it will take some time. Meanwhile, I will pause the video. So friends, our model creating process is completed, and our model save inside runs, detect and train folder, and this is what our class, as you can see, the person and forklift. So if I go runs, then detect, then train, and then weights folder. So this is what our basic model which we are going to use without configuring Google Coral USB Accelerator on Raspberry Pi 4. So let's just first cross check if our model is perfectly detect our object. So for that, here it is, as you can see, the next cell where I have mentioned the model path from base.pt. This is what our model path, and the image file which we are going to use from images folder. From images folder we are going to use img image number 36. Simple. So let's just run our code. Process completed, and results save inside runs, detect and predict. So runs, let me make like this way, runs, detect and predict, and inside that we have our image which we select. So if I just double click on the image, and as you can see, there is a result, the person, the forklift, and there is also person, and we successfully detect our object. So now what we are going to do, we are going to download the base.pt model, and we are going to detect our object without Google Coral USB Accelerator. As I mentioned, this is the basic model which you use without Google Coral USB, and then we are going to convert. Here it is, as you can see, the last cell for converting base.pt, our basic model, for HTPU device. But first let's just download our basic model for without Google Coral USB. So we have our model inside train, then weights, and then base.pt. So just click on double download, and now it's downloading our base.pt, and then we have our base.pt model inside our download folder. So just open downloads and then base.pt, this one, right click, cut, go to the home and our repository and just paste it here, right click and paste, and then we are going to open our Thony Python IDE. As I mentioned, we are now in our virtual environment, so go to the file, click on open, and then from our repository main.py, and then here we need to mention our model base.pt, and for classes we are going to create a custom class file which is coco1.txt, new file coco1.txt, click on OK, and then coco1.txt, right click, text editor, it will open up our coco1.txt with the help of text editor, and here simply we are going to mention our two classes. So first one is person and the next one is forklift. Done, file, save, and then close it. So we have done with all the things, and simply we are going to run our code. Intended block. Okay, let me check here. CV zone put text rect from C. There is mistake in intended block, so let me check like this way. This will come over here, and this will, oh, because we mentioned here ellipse, so this will go here. That's why there is intended block. The line, the code line is not in the line for if function. Simple. So let's just run our code. And friends, as you can see, this is what our detection result. Forklift is there, and inside the forklift we have person, and here also we have person. This one is also person. But as I mentioned, this is what we are doing without Google Coral USB. Also, I am same time recording on Raspberry Pi 4. That's why it is really slow. Now simply we are going to convert our model, our basic model, for HTPU Google Coral USB Accelerator. So we are successfully detecting our object. So let's just stop our code and again open our Google Colab machine, and let's just run our last cell. It will convert our model into HTPU. As you can see, the process is started. So friends, we successfully convert our best.pt into best full integer cont HTPU.tflight model, and our model is saved inside weights best save model folder. So if you go here, runs, then detect, then train, then we have weights folder, and inside that weights folder we have best save model. So just click here, and then our model name is best full integer cont HTPU.tflight. So best full integer, as you can see, this one full integer, which is 3.27 MB. So just click on here, click on download, and it will download our model for our Google Coral USB Accelerator. And we successfully download our model. Then go to the downloads here, and this is what our model. Right click, cut, go to the home and our repository, and then just paste it. Then just right click to the model name, rename, and then just copy the name, cancel it, and open Thony Python ID, and here we want to mention our model name. That's it. Save the code and run the code. So friends, as you can see, as I mentioned, because we are using now Google Coral USB Accelerator, it's really fast. And same time I am recording on Raspberry Pi 4, but it's working really good. As you can see, we are detecting this forklift. Also inside that forklift we have person. There is a person. Here also we have person. And it's really working good because we are using Google Coral USB Accelerator. So with the help of Autodistill, simply you can automate the labeling process for Raspberry Pi 4 also. So you can use the model without Google Coral USB, which is the basic model best.pt, and with the help of converter you can convert the model for Google Coral USB Accelerator also. As you can see, this is the result in front of you. We successfully detect our custom object, which is the forklift. Also detection is really good. We are detecting the person, also we are detecting the forklift. As you can see, the result is in front of you. So I hope you will learn something from this video. We will meet our next video. Till then, thank you, take care, and bye bye.